In this lesson, we will learn about normal maps and how they are used. Normal maps are similar to bump maps in that they both affect the normals of our geometry and create the illusion of detail without having to rely on a high poly count. The major difference is that bump maps simply encode height information using black and white values, but normal maps actually use RGB values to signify the orientation of the surface normal. The information written into red, green, and blue channels of the normal map correspond to the X, Y, and Z orientation of the surface normal at any given pixel. The use of normal maps has become commonplace in many of today's video games, where game developers can take a highly detailed model and bake all of the surface detail into a normal map, which can then be applied to a low polygon model in order to create the illusion of high-resolution detail. There are two basic types of normal maps, tangent space and object space, and each has their own benefits. Tangent space normal maps are primarily bluish-purple in color and can be used on meshes that need to be able to deform, such as an animated game character. An object space normal map have more of a rainbow-like assortment of colors and have slightly improved performance compared to tangent space maps. Object space maps can be used for objects that need to move and rotate but don't necessarily need to deform, such as a game weapon, vehicles, or buildings. By allowing artists to transfer high-resolution detail onto a low-resolution mesh, normal maps have allowed for significant advances not only in video games, but they are also allowing feature film studios to render high-quality detail on CG characters and scenes much more efficiently.